Hey everybody, welcome to another Thatcher walkthrough. I'm Jason Stahl. You can see we've got some work done. It's on landing gear, at least on the mains. We're waiting on the nose strut to come in so we can finish all three. But we've had some success on that. We'll talk about some of the issues I've had getting the brakes installed. The rudder pedals are starting to go in. The rear, having some geometry issues. We'll talk about that also. Dave Thatcher has come up with some plans revisions that came out a couple weeks ago, and there's some significant measurement changes. The space for the rear empennage has actually changed the dimensions. It was originally, I believe, 20 inches, is now 22 inches. So we want to make sure we look at that. The design for the mounting of the nose gear has changed. I'm not going to redo it. Dave was saying that his goal was to make it easier to machine. I've already machined it, and Glenn Bradley has said that he's had no problems with the strength or issues with that, so I don't think the previous design has any flaws that need to be corrected. So we're going to leave the front as is. So let's go take a look at some of the build and show you what's going on. First up, we have change to the nose gear, the mount. So before we had a hole that had to be machined in the bottom and an angle to reinforce it. Dave said that he wanted to get rid of the machining. It was kind of hard to accomplish, a little fiddly to keep it strong. The new design eliminates this hole. This angle is now two parts. This angle is increased in size to 3/16 as this and moved to the front on here to reinforce what is now two pieces. These two vertical angles drop down past that into the gap and drop down an extra inch or two. As you can see, I've got the wing root all done and skinned, ready to rivet, still keeping it cleat-coated so I can access the interior to run fuel and airlines. This flanging hole was bent with a bob stick. I've purchased two flanging dies. The Sonex uses the same stock size of holes for the lightning holes as the Thatcher, 4-inch and 3-inch diameter holes. So they have a kit of two dies. They're injection molded for about $57, $58. They work very well on the 032 and thinner. For 040, people have said that they do tend to split when used hard, so I didn't want to use it on this. I used a bob stick, which is basically just a piece of wood with a slot cut into it. Many videos on how to do it. It worked out really nice and it makes a good flanging hole. It's just long and tedious, and the flanging dies can produce the flange and the thinner ones in a matter of seconds. So take a look at the website for that. They work out really nicely. As you can see, the motor for the speed brake has been installed. I started work on that just like a day before the plans came, the revisions came that had more details on the installation of the gear motor, which would have helped some of my geometry for the control throws, but I've got it to work. But we'll talk about what can make it even a little easier. The plans drawing shows that the pivot point should be in a straight line from these ridges. But if you come out directly opposite of that, you don't have enough metal to make that 2 inches away. You need the 2 inches to get the control throws correct. Otherwise, you won't get full deployment of the speed brake. The first place where you could actually mount it and have a 2-inch throw is right about in this area, and that would improve the geometry of in here. I've got this to work, so I'm going to leave it over here, but if you can move it as far in line with these ridges when you drill this, the better. Also, if you can kind of cheat it so that the movement moves it back and forth. I unfortunately did it mid-throw on my positioning and lined it up. Mid-throw, it should have been probably a little bit over here. That would have minimized how much further back. It just gets tight at the very end of the movement in here, so we're not really binding. It just, at the very last tooth, it just gets tight. So I will actually put my limits electronically in here, and I'm looking at actually using a Vertical Power VPX Sport, which has a built-in trim and flap controller if you're doing electric trim, which I'm considering but haven't decided yet. The main goal of the VPX unit is an electronic circuit breaker, programmable at that. It's got over a dozen circuit breakers built into it, and you can program when they trip. So it's really kind of neat, and it plugs into your ethos, and you can redo all your resetting and fault checking through the ethos. Neat little unit, check it out in here. So I can program soft limits in here and avoid any kind of binding. You do need to cut this off on this side because it is too tall for the height of here. One solution, I've seen pictures of one of the builders, they actually moved this further back, had a longer control arm, which improved the geometry, so you minimize binding, but it was too tall, and he actually had to build up a little bit of bulkhead and raise the seat about an inch, inch and a half, it looks like on here. You do have good headroom in the CX5, so your passenger probably still won't be close to bumping their head, but it is doable to put this in per plans and keep it all tucked in here. That's how it works. One suggestion, when you're installing this, you're going to want to move this back and forth in the quadrant to check your control throws. It's handy to have a battery and your switch that you're going to use and wire it up with your polarity reversing so that you can quickly and easily move your motor through the control range. If you don't use a battery, you can use a power supply in here, but don't use a little 500 milliamp. When I was doing this, I was using a digital power supply, and it looked to be drawing almost 2 amps at full speed. So if you've got like a laptop power supply that's 2 to 5 amps, that would work out well. You can hook it up to a little battery, a little gel cell battery, and do it that way too. But really handy to be able to move that back and forth, almost pretty much required. And this will not move on its own. You cannot budge this motor by hand. It is just geared way too high for that. In your retracted state, this horn should be slightly above horizontal. It's kind of hard to tell here, but it should be a little bit above. In full deploy, it comes down about here, not straight down. It's at a little angle, basically pointing directly along the line of its mounting point on the actual speed flap. The total throw, I did some math, I came up with about 78 degrees. So you don't even need a 90-degree throw to get it to fully actuate it. Cut holes in here. If you haven't riveted your bottom on here all the way, it may be good to mark it, pull it off, and take it to a jigsaw or something. I've already had this riveted, so I had to do it in situ. Made it rough. I may make a nice plate that I can rivet to make the bottom look nice, but again, when it comes up, the speed brake is actually covering the hole and is not visible. It's not in the airstream. So it really is not consequential to that point. As you can see on the left-hand side, we've got the reinforcements for the wing walk. That is only on the left side. As you don't, the canopy swings over on the right. So these braces are not needed on the right side, just on the left, and I've got them on the nose also. Let's talk about the bolts for the landing gear. You can see I've got one bolt on, one nut on, the other one's left in here. The AN5-20 is a little long. You can see that there's quite a bit of shank sticking up through there, almost a quarter of an inch. A dash 16 or dash 17 is probably the more ideal bolt. I've actually got a set of each one of those coming and finding out the exact one. You just have to stack way too many washers on it. And this is stock per plans, just the two stack longerons, the support plate on the bottom, and then the 3/4 inch landing gear in there, and you still have a little bit too much length. So a dash 20, a little too long. If you want to order, they're only like 40 cents a piece. So order some 16s and 17s with your 20s, just so you can find the exact right bolt in there. When you get to the brakes in here, you notice that you've got to drill your own holes through the landing gear strut. But what you're also going to find is that you're going to have to re-drill holes into the axle. If you buy the parts in the parts list, you're to buy the axle and plate pre-welded from Great Plains, which is now O'Keefe Aero for the brake and axle components. and the brakes from Tracy O'Brien. They are different bolt circles. If you look at the specs, you would think that they're only 50 thousandths different, which it would be inconsequential. You could really just kind of do that, but they measure them completely differently. The Tracy O'Brien bolt circle is measured as a true diameter of the circle, whereas the bolt hole spec on the axle plate is the distance between two adjacent bolts. And it is a much bigger bolt circle than the brakes. So you're going to end up having to drill a new bolt circle on the plate. It is not easy to do on the pre-welded. If you have the ability to do welding, I would suggest you buy it unwelded and re-drill the new holes before you weld it up. It would be much, much easier to do it that way. I didn't, so it took about a total of two and a half hours of work to do that. So you can save yourself some problem if you buy it unwelded and weld yourself, or even just fab it up yourself, and you don't have to even have the incorrect holes in there. But really, it's kind of not much of a consequence. When you do drill it, try and keep your feed and your bleed valves up at the top. That will make sure you're able to get all of the air out of the system easily, and you won't have mushy brakes. There's been some issues. If you look on the forums, Tracy O'Brien brakes, people have complained that they are mushy and not effective. They really should be. If you get all the air out of the system, you've got a lot of brake pad surface area. And the drawback is that they don't cool as well as if they were just on a portion of it, but your braking on an airplane is only 15 seconds at a time, maybe some when you're taxiing. But you want to just be aware that these don't cool as well as a normal brake system would, but they should have plenty of grip. Let's talk a little bit about the rudder pedals. I haven't started the front ones. I'm still waiting on some materials to come in, but the rear ones, we've got the platform built. Everything's been welded up and mounted, but the geometry is a little different than what I was expecting. The drawing shows that these brackets should be flush to the outside. We are here on the right rudder pedal. If we build that to plans, that moves this rudder pedal way to the edge of here, starts interfering with here, and definitely on the other side would interfere with the aileron torque tube right over here. It actually would not even fit in there. So we started playing around with it. We moved the brackets to the center. That worked better, but we'd still have interference with the armrest. The armrest would come in, drop down, and is supposed to attach 2 inches inside of the outside skin, which is a ½ an inch from the longerons. This platform goes right up to the bottom longeron in here. So I think ideally this bottom footrest probably should be 3/4 of an inch narrower. It's the plans say 5 1/4. Maybe it should be about 4 1/2, maybe 4 3/4 to give you a little bit more room for your armrest sheet metal to come down in here. On this one, I've actually played with it more and moved it all the way in to the other side. Instead of flush to the outside, it's flush to the inside. That gives my geometry correct for my bolt to go through the hole and clear the elevator control horn and move to the front. The only issue I am concerned about is that now I've got a fairly narrow gap where the pilot's legs have to go through. Your hip slant knees are right in between these points. And I've got a request to get a measurement on the prototype to find out on theirs how much room they actually have. Right now I've only got, if I put this one here and the other one likewise, that only gives me about 12 inches between. Now granted, it doesn't go up very high and my knees may actually be above that, but I'm just a little wary about that. So we're still working on geometry of the rear rudder pedals. We'll have definitely more information on that in coming episodes.